Hello, Algebra 2 Trig students. We are back with Unit 3, Lesson 3, and it is going to be all about polynomial long division. So if you didn't do the warm-ups, I would go ahead and stop now and do the warm-ups, especially the long division, to get your brain back into what we do when we do long division. So if you didn't do the warm-ups, pause now and check the answer key, because obviously I don't have the answers here. All right, hopefully you did okay on the warm-ups. Now we're going to move on. It says, long division with polynomials works just like long division that you did back in elementary school, except now you'll be dividing with variables instead of just numbers. So we're going to do that here. It says use long division to divide the polynomial 2x squared minus 5x plus x cubed minus 6 by x minus 1. Okay, so step number 1 before you should do long division is to take what is being divided by, the dividend, right? This is the dividend, and you put that in descending order. So take the dividend and put it in descending order. X cubed is the highest, 2x squared is next, minus 5x, minus 6. So we put it in descending order, x cubed plus 2x squared minus 5x minus 6. We are dividing by, right, x minus 1. So this is the divisor. So what's underneath is the dividend, then we have the divisor. You need to make sure your dividend and your divisor are both in descending order. Now we're going to do our long division. We take the first term of the dividend, x cubed, divide it by the first term in the divisor, x. So x cubed divided by x. Hopefully you're saying to yourself, well, that would be x squared. Then I take the x squared and I multiply. X squared times x is x cubed. X squared times negative 1 is negative x squared. And I would get x cubed minus x squared. Then I'm going to subtract. Right? That's what you would do if you were doing this yourself. You would subtract the number you got. So we're going to subtract. I like to just physically change the signs because otherwise I think I make mathematical errors. So we get a negative x cubed. When you subtract, those first terms should cancel. If they don't, you've made a mistake. Then we have 2x squared plus x squared, which is 3x squared. So I'm going to add that up, and then I'm going to bring down my next term. So we should be keeping track of what we did here. So number 1, what did we do? We did division. We divided first term by first term. Right? So first term by first term. Number 2, what do? We multiplied through, right? So that's my yellow part, right? That was the yellow. We multiplied. And then what do we do next? We subtracted, so we changed the signs. So we subtracted, and now we are going to bring down the next term. Sorry, I'm writing so messy. I don't know what's wrong with me. Bring down the next term, which is what I did here. Now we repeat the process. So the 5th one is repeat steps 1 through 4. Right? So we go back and we repeat and do the same thing. So first term, 3x squared, we divide that by x. 3x squared divided by x, hopefully you're saying is a positive 3x. You need to put the plus sign there, so we get a positive 3x. Now I multiply, right? So 3x times x is 3x squared. Positive 3x times negative 1 is negative 3x. Then I subtract. I'm on step 3, subtract. I like to just change the signs. So it's negative 3x squared, those cancel, positive 3x. Then I add those up. Negative 5x plus 3x is negative 2x, and then I bring down my last term, which is minus 6. I repeat the process one more time. I take x, negative 2x divided by x is negative 2. I multiply, negative 2 times x is negative 2x. Negative 2 times negative 1 is positive 2. I change my signs or subtract. The first term should cancel, and I end up with negative 8. Okay, so what do we have here? We have our quotient, which is x cubed plus 3x minus 2, and we have our remainder of negative 8, right? So this is a remainder. This is our quotient in green. So what does that mean? It means if we took 2x cubed minus 5x plus x cubed minus 6 and divided it by x minus 1, we would get, let me see, where can I write this? X cubed plus 3x minus 2 is our quotient, and then we add our remainder, but our remainder is negative, that's why I'm subtracting, which would be 8 over, and then what we divided by. So this is essentially what we would get if we did that long division. This is our quotient, this is our remainder, this is our dividend. Okay, now we're going to use that in different ways where we won't have remainders. So let's see what we do from here. All right. So it says divide 2x cubed minus 9x squared plus 5x by 2x minus 5. So this is already in descending order. We're going to take that, I'm going to put it underneath. This is my dividend. Now, one of the things that I highly recommend you do, you don't have to, is to put a placeholder here. The 0x, notice there is no x. Well, if you put the placeholder, it's just going to help you organize your final answer. So we have an x cubed and x squared. We don't have an x, therefore I'm going to put a placeholder there, a 0x, and then you have your constant of 15. We are dividing this by 2x minus 5, and then I'm going to follow the process that I did before. Step number 1, take the first term and divide it by the first term. So 2x cubed divided by 2x is x squared. Then I multiply through, so 2x times x squared is 2x cubed. Negative 5 times x squared is negative 5x squared. Then I subtract. So in my mind, I'm just going to change the signs. That's what subtraction is. And my first terms should cancel. Now I bring down negative 9x squared plus 5x squared is negative 4x squared. And then I bring down my 0x. Okay, we go back to division. 2x goes into negative 4x squared how many times? So negative 4x squared divided by 2x is negative 2x. I multiply through. I change the signs. And I bring down my negative 10x because I added, and then I get my plus 15. So again, you should be trying to do this on your own. You could pause and try to finish it, right? So try to do this math on your own so you're exercising your brain. Don't just rely on me to do the math for you. Once you get the hang of it, just pause and try it on your own, and then look at my process here. Okay, next, we're doing the same thing. Negative 10x divided by 2x is negative 5. I multiply through. Negative 5 times 2x is negative 10x. Negative 5 times negative 5 is positive 25. I subtract, which means I change the signs, and I get a remainder of negative 10. So when I do my long division, what would I get? So 2x cubed minus 9x squared plus 15 divided by 2x minus 5 is equal to x squared minus 2x minus 5 minus 10 over the dividend. All right, I would try example 3 on your own. So your numerator is what goes underneath the division bar, right? That's your divisor. The denominator is your dividend. Make sure they're in descending order, right? So I'll help you get that set up. So I'm going to put this in descending order, 4x to the 4th plus 3x cubed. Oops, I don't have an x squared, so I'm going to put a placeholder there. So I had to do it in descending order, and I had to put a placeholder. Then I'm going to make sure what I'm dividing by, or my divisor, is also in descending order. So go ahead and pause and try this one on your own. Okay, so did you get a quotient of 4x squared minus x minus 7 and a remainder of 11x plus 15? Hopefully you did. If you didn't, then you made a mistake and you need to go back and check. So just to review our vocabulary, right, the numerator, what we are doing, what is getting divided is called our dividend. What we are dividing by is called our divisor. What we get as a result up here is our quotient, and then sometimes we have a remainder left over, or sometimes our remainder is 0. If it's a remainder of 0, that means it divided evenly into that. If it's not a remainder of 0, that means obviously it didn't divide evenly. So let's continue. I would say pause again and try example 4 on your own. Do part A only, and then we'll talk about part B. So part A, we're going to take I'll help you get started again. We're going to take our polynomial, our dividend, x cubed plus 6x squared plus 13x plus 12. Remember, it always has to be in descending order. And we are going to divide that by x plus 3. So pause, do this on your own, and then compare it with my answer. All right, so this time when you did your long division, you should have gotten a remainder of 0. So x cubed plus 6x squared plus 13x plus 12 divided by x plus 3 resulted in just x squared plus 3x plus 4. So it divided, x plus 3 divided into that evenly, and it had a remainder of 0. So what happens with part B if we evaluate f of negative 3? So that means we're putting negative 3 into x, right? So that's a negative 3 cubed plus 13 times negative 3 plus 6 times negative 3 squared plus 12. So I'm going to get negative 27 minus 39 plus 54 plus 12, right? If you can't do the math that quickly in your head, well, just look at it now or pause and try this on your own. So here, my negative numbers, I have negative 66. My positive numbers, look at that, I have positive 66, so that is 0. So when I plug in negative 3 for x, I got 0 as a result, right? So when x is negative 3, y was 0. Okay, well look at this. If we divide by x plus 3, that would be a root of negative 3. If it divides into it evenly, that means graphically there is a root at negative 3. So how do these two things connect? Well, let's talk about it in the next slide. Okay, well, it leads us to the remainder theorem. The remainder theorem says that when a polynomial p of x is divided by x minus a, the remainder can be found by calculating p of a. So if we just plug in this number into our function, then we're going to find out what the remainder is. If p of a equals 0 when we plug that number in, then it means it's a factor of the polynomial, or it's a root of the graph, right? But if we get a numerical value, we have just found a point that is on that graph. So let's talk about that in example 5. It says find the remainder when f of x equals 2x cubed minus 3x squared minus 11x plus 6 is divided by x plus 2. So we have two options now. We can do long division if we want to find the remainder, which is going to be time consuming, as you saw from our previous examples, or we can use the remainder theorem. The remainder theorem says just take p of a. Oops, sorry, that shouldn't be a plus sign there. A is equal to what? Well, a is equal to negative 2. So if I take f of negative 2, right, so 2 times negative 2 cubed minus 3 times negative 2 squared minus 11 times negative 2 plus 6, and I need to calculate this. So you guys can pause and go ahead and calculate on your own, or you can follow me. So I get a remainder of 0, right? So negative 16 minus 12 is negative 28. 22 plus 6 is 28. So negative 28 plus 28 is 0. So that means x plus 2 is a factor of f of x. So if I were to divide f of x by x plus 2, I would get 0. So in other words, the point -2, 0 is on the graph, and that -2 happens to be a root. That's where it crosses the x-axis. Now let's look at the second example. So if I'm dividing this by x minus 1, then a is equal to 1. So I'm going to find f of 1. So it's 2 times 1 cubed minus 3 times 1 squared minus 11 times 1 plus 6. Well, that's 2 minus 3 minus 11 plus 6. So what do I have this time? It looks like I have -6, right? 2 minus 3 is -1, minus 11 is -12, plus 6 is -6. So this time we're saying when you plug in 1, you get a remainder of -6. It is not a factor. So x minus 1 is not a factor, but the remainder does allow us to see what point would be on this graph if we were to graph it. So when I plug in a 1, I get a remainder of -6. Well, that's just my x and y coordinates. So that means point 1, -6 is on this function. But when you're doing long division, if you get a remainder, that means it's not a factor. This was a factor. X plus 2 was a factor of the function. X minus 1 is not a factor. All right, try this last one on your own. And then you can unpause and listen to me explain it. Okay, hopefully seeing what I just did above with this problem right here, you can figure out what this question is asking you, example number 6, what it's asking you. So it says when a polynomial f of x is divided by x plus 5, the remainder is -2. The remainder is -2. So your remainder is -2. So circle the statement below that best describes the situation. Well, if I'm dividing by x plus 5, that means I would be using the remainder theorem. It would be f of -5. And if I plug in -5 into the function, I would get -2 as a result. So that means the point -5, -2 would be on this graph. And what represents that, oops, sorry, that's not a negative number, would be letter D. When I plug in -5 for x, I get -2 as a result. So the remainder is the y coordinate on the graph. And if it is a factor, that y coordinate will be 0, and it will go through the x-axis at that point. If you get a numerical value, well, you just have a specific point on that graph. Okay, hope it helps. Good luck with homework. I'll see you or hear you or listen. You'll listen to me in the next lesson if you need it. Ask your teacher if you have questions. Bye.